In the following exercise, I'm going to show you guys how we would use arguments in a script that we have been playing around with for a little bit in class. And that script is the one that we've been using to look at latitude and longitude for the Mars Claudius data file. Specifically, it's this script over here on the right, where we've used the RE module to look at that file, loop through the file, and then gone through and generated calculations for decimal degrees, for latitude and longitude, isolated the ROV and dive number for each observation, and then finally are outputting the information of ROV, dive, latitude, and longitude. So if we run that script, we can see that we're going to get an identifier of the ROV, the dive number associated with it, the latitude, and the longitude. So in the following example, what I'd like you to do is to take that code that we've generated here, and we want to be able to write a script that uses arguments to identify the file that we want to examine, the file that we want to write the output of our information to, and in this case we're going to output depth, latitude, and longitude, and we're also going to set a depth threshold below which it will report data. So we want to be able to run all these things from a Unix command prompt, and so there's a little example here of how you would call this script. You first would write in Python the name of the script, and then you'd have a series of arguments that would then help define the behavior of the script. So we're going to use this as the basis. First, one of the things that I wanted to do was to demonstrate how we might use some of these scripts. We might make some small changes to this script. So first, one of the things that I just want to point out as a little aside before we get to the arguments part is we have some redundant code here, We're basically doing this calculation for latitude and longitude and converting it from decimals, hours, to decimal degrees. And what we'd like to do is to try to minimize how much redundancy we have in our code. So to do that, because we're doing something twice, you might think we're going to use some sort of structure like a loop or something of that ilk. But in this case, what we're actually going to do is we're going to generate a method. So here I'm going to write a function. I'm going to create a function to calculate decimal degrees, and we use that def definer to establish the function, and then we're going to give it a name. And so I'm going to call it decimal deg, and we're going to pass in one parameter to decimal deg when we call it, and that's going to be called the degrees string. And in order for this to work, it requires the RE module, which we've already imported. It's basically going to take a string in the format of degrees and then minutes. So say something like this with a direction, and it's going to return decimal degrees. And the first thing we're going to do to make this function work is we're going to just go down here and see what the steps are to do this kind of calculation before. So here we can see that this section indicates the section of code that is also repeated here for longitude. So what I'm going to do is I'm going to take this code and I'm going to insert it here underneath this function. I need to adjust the tab. So we're going to move this code back here. And then we'll do a few things to slightly generalize the code. So one, we have our search string that we're going to create. We're then going to generate a result object using that search string. And instead of identifying a key element list or the thing that we're going to search, what we're actually going to search in this case is going to be that degree string. So this is the parameter that we're passing into this method. Then from that, we will set degrees and minutes, our decimal degrees, we have our if statement to account for whether or not we are looking at compass reading of south or west. And then finally, we're going to return our decimal degrees value. So with this, we've created our function called decimal deg. And now if we go back to where that piece of that sequence would have been called, we can say something like lat decimal degrees is equal to decimal deg element list position 2. Similarly, all of this code will change. And instead of having to have all this additional code, I can use the same function or method, just indicating a different degree string in a different position, and calculate the same outcome. So here we can say use method to calculate decimal degrees. One thing that we had here, however, is that we had this command all set up. We now want to actually only output data if it is below a certain depth threshold. If we were to look back at our data, we can see that depth is actually in this 5th column, or what would be our 5th position or index number 4 in this file. So if we want to make this output statement dependent upon that, we could say something like if depth threshold is greater than, if depth is greater than some sort of depth threshold, which we haven't yet defined. All right, if it's going to do that, then we consider doing our output command. We also might want to add in that depth value. So we could easily do something like add in extra position and set depth. Again, depth is in the fourth element of the list, so if we wanted to create that, we might create a variable called depth and set it equal to element list position 4, converting it into an integer because this is comes in as a string. Right? We still haven't established this threshold or established how we're going to write this input and this output file. So how would we consider setting this input and this output file instead of in a fashion like this, but doing it from some kind of argument? We're going to have to start by importing in the sys module, right? Again, you could have gone and done what we had talked about previously in class, which is instead of going to go create all of this code from hand, we just could have imported it from an existing exemplar. So in this case, we could take a case such as the one shown here, right, where we had an example of code that we already know works, right, where we could take a usage statement. So here I'm just going to take this set of code that we went over today in class. I'm going to use that as the basis for what I'm going to put into my script. So after I import that sys module, I'm then going to create a usage statement. I'll say if the length of sys.argv is less than 2, then I will offer some information. This script is for outputting data from ROV samples. I'll then add the usage. It'll be LatLong.py. Then in data file out file results file, and then d depth threshold. Next, I'll print the usage for each of these arguments. So input file, output file, and then we'll use sysexit. So now we have our usage statement. Next, I'm going to parse the arguments. So we'll start off with for I in range length sys.argv, and we'll say if sys.argv position I is equal to dash in, then in file name is going to be equal to sys.argv position I plus 1. We'll then add in elif conditions for each of the other parameters. So that everything can be set accordingly. In the end, nothing else needs to be added, as in file will now be set. I will create the out file for writing. Open I'll add in the depth variable too, so that it's there earlier. The only thing left to do now is adjust the output. So I'm going to set this equal to out string. And we'll then write this to this new file. And lastly, we will close file objects. Again, this is in Jupyter, we want to run this whole thing as a script. But now we've got it set up so that we've got our 3 arguments identified and how they're being used up here. Those arguments are then parsed into these 3 variables, which are then used to set the in file and the out file name for the file objects, as well as the depth threshold that is used later in this loop in order to dictate what will be expressed and won't be expressed. All right, so what I'm going to do here, because I want to run this as a script, so we're going to take this code, we'll put it into a script. Save this as a Python script. can now see when it runs, it gives us its usage statement, and now we can try to run it as identified above. We'll tell it where the file is. The file is actually in this location. Notice that I can use the normal Unix tab function to identify the file very easily. Oops, made a little mistake there. Didn't follow my own directions. It's not out, it's O. So after we run the code, if I now go back to the directory, find the out file, we can see that it has outputted all the dives that are below a certain threshold. If I wanted to further change that, I could add it, make the threshold more strict. And we could see that it's only going to put out items below 1,000 feet now. So that's how you would answer this question. Again, we're taking these arguments and we're using them to determine the name of the in file, the name of the out file, and the depth that you would use. In other words, changing the behavior of the program, where it's identifying the file, how it's what it's writing the file to, and which data it's choosing to output. Thanks for your time.